Thank you. So let's start this. Getting started with libcurl. I've done this presentation before. I've modified the tiny details in it, but anyway, this is me. I'm Daniel. I'm sitting in front of this desk right now when I'm doing this presentation. I work for Wolf SSL. That's my website. So today, I want to go through a few things then how that you might consider or face when getting started with libcurl development, right? Some of the basics of libcurl, the synchronous blocking transfers, how to get information from, well, internet transfers, and how briefly how to do spice things up and do concurrent transfers, and a few words of about the URL parser. So pretty basic stuff, and I'm going to keep a fairly high pace. So if I miss something, or if I touch something that you're more interested in, hit the Q&A button, ask me, and we can sort of dive into those details afterwards, or you can read up on them afterwards. But anyway, I'm hoping to give you a little bit of a taste of everything and then get to the questions in the end. And I'm not in a hurry. We can do a lot of questions if you have a lot of questions. Let's hope I manage to answer most of them in this presentation. So I want to start out by saying that curl is usually curl and libcurl. Curl, the command line tool, and libcurl, the library. Usually we write the curl project as with the uppercase URL, like and a lowercase c in this manner. Sometimes we don't, so we sort of mix and match them a little bit. But the command line tool is often then called curl with lowercase, and the library is libcurl. Anyway, that's sort of the basics. I tend to be a little bit of a inconsistent there, so I tend to sometimes call them curl interchangeably. And today, I want to emphasize then that we're talking about libcurl, the library with the API, how to do internet transfers in your application, really. Libcurl is MIT licensed. It's not strictly MIT, but it's in essentially, it is next to an MIT license. It has the same conditions. It's actually a tweaked MIT, so it doesn't, I mean, it's not exactly identical, but still it's the same. And of course, there's commercial support available. I'll get back to that quickly in the end too. So when do you want to use curl? When you want to do internet transfers or data transfers using URL, using one of these protocols. So 28 different protocols or URL schemes are supported by curl. They're all in the style of doing uploads or downloads or both. And things over network. Actually, it also supports the file : / URL scheme, which is not necessarily over a network. But anyway, so when you want to do one of those and you want to use one of the many features that curl supports, then curl is the thing for you. And of course, curl also is extremely portable, so it runs everywhere. So, and it is already used everywhere. I tend to use this image just to give you an idea of in what kind of devices curl is already used. You know, cars, TVs, game devices, printers, robots, fridges, loudspeakers, games, consoles, and virtually anything that is internet connected could or is running curl already. So, so start with things. So, of course, when you want to do something with libcurl, you need to get it first, and right. And if you're using Linux, there's going to be a libcurl package in your Linux distribution. And if you're using Mac OS, you can install it with Homebrew or Mac ports or whatever. And there are plenty of different ways and mechanisms that you can get it installed. And it's also actually a fairly easy thing to build it yourself and from source code and use that. And if you do build it yourself, you pretty much decide to go with either the configure way, the CMake way, or building with Visual Studio files. We sort of push everyone towards configure or CMake these days. And when you do that, you have the option to enable, disable support for specific protocols or features, or exactly which third-party library you want to use for different features, such as compression or TLS or SSH, etc. And using this approach with the configure and CMake actually is really easy to just cross-compile your build. So if you want to build for a more exotic operating system, it's fairly straightforward. Anyway, so when you've built libcurl, you have a libcurl there, you want to build your application to use that libcurl, and then you just tell the compiler where to find the include files and tell the linker how to use libcurl, right? So if you, in a typical Linux distribution, you basically just do this. You use your compiler, tell it to link with the curl library, or it's called libcurl then, but it used with -l curl, the source file and output. And in most distros and installation situations, the include path is already, it is installed in the default include path, so you don't have to specify where to find the includes, it's just there. So this is how you do it in most Linux distros and homebrew and stuff like that. You might, of course, have to tweak it a little bit depending on if you're doing it differently. And I also want to emphasize that because of this wide range of different places that you can get libcurl from, or you can build it yourself. And as I mentioned, you can enable, disable protocols, features, different third-party libraries and everything. You will find that there are many different versions or different flavors, different kinds of curl and libcurl wherever you go. So they might be slightly different. They might build and be used on different platforms, and then have all of these different features enabled or disabled at runtime. You can disable, you can enable, disable features at build time, of course, and different backends you can enable, disabled at build time. For example, you can choose which the TLS library you want to use in your libcurl, and we support 12 different TLS libraries, and you select which ones to support at build time. But then actually when you can select a number of TLS libraries and select which one of these at runtime. So there's a mix and match really that is, well, sometimes complicated, but it also gives you an immense power to make it do exactly the way you want it. You make it use exactly the components and features you want it to use. And I'm very proud to say that we have a lot of documentation for curl and libcurl and how to use it, and we take documentation seriously. And I hope that you will find out and you will learn that if you try to figure these out yourself, or if so every function, everything I'm going to talk about today, and all libcurl functions has their own man pages where they are documented clearly with examples and see also, and everything documented in detail. And every option, you'll see that we have a lot of options to some of these functions. Actually, we have in total, I think, close to 450 in total or something. So it's a busload of them, whatever load. And each and every one of those options has its own man page as well, thoroughly documented, detailed with examples, etc. And there are also a bunch of standalone examples on the website and in the release distribution turbols that you can find to sort of get inspirations from and see how do you do this in a completely standalone small example application. And everything is always updated and available on the website. The latest one is always present there on the web. And we also have this book called Everything Curl, which provides even more resources and sometimes more of a tutorial explainer-like documentation. Sometimes the man pages are a little bit more, you have to know what to look for to know which man page to search for example. The book Everything Curl is meant to be a little bit of a more casual explainer thing. Maybe get started there. And it's actually really easy. If you have a function or option name in curl you want to learn about, just Google it. It's really easy to find the correct documentation URLs or web pages like that. In libcurl and the curl project, we work really hard, and one of our sort of main missions in life really is to never ever break the API or ABI. That means that upgrading to the next libcurl is always safe. It won't break your application, so you can always upgrade to the latest. You can, in fact, examples that were built in the early 2000s can still be built with the latest libcurl today, and it runs fine. Usually all the URLs and everything else you used 20 years ago, they have broken since, but the API and the API they have not. So features remain, and it's really stable and solid. And also a very nice feature, I would say, about the API, the libcurl API in general, is that it works the same on all platforms. So you can write your application using libcurl on one platform, and you can transition that to another platform tomorrow. Or you can write your platform, your application in a multi-platform way, so that you can easily support many platforms, and they all run libcurl and they support it the same way. Really convenient, actually. It also makes it convenient when you want to write a test application on perhaps one operating system and then run that on your target operating system. There can be different operating systems, but you can still write the same application code. The API in libcurl has we have a few groups basically, and we group them by prefix in the name of the function. So we have the easy functions, the easy family, curl easy interface, we often call it. They're prefixed by curl easy, like this. And we have the multi interface, curl multi. We have the share interface, curl share, the URL parser, the URL interface called curl URL. And yeah, well, you can follow the pattern here. So you can sort of recognize all the names in the libcurl API like this, the easy multi-share. And today, I don't think I'm going to mention much about the share interface, but the easy I'm going to focus on and touch the multi-interface a little bit, and quickie on the URL API towards the end. Okay, so a few principles about the libcurl API is then that it's oriented around transfers and URLs. Pretty basic, right? And I hope you anticipated this. But pretty much libcurl is made for doing transfers, right? And it is made to work with URLs. Provide a URL and curl will do the transfer. So that is what you do. You set up and perform transfers, and each transfer has a URL. It is actually the only mandatory option for a transfer. You have to provide a URL. And if you don't provide any other option, that URL means download that URL content. And that is what curl does then, but it can also, of course, upload. And then that's the basic stuff. And then you have to provide a lot of options to tell curl exactly how to do that. What does it mean? What do you want from that transfer? And one of the ends in the transfer, either up or down, is a URL. The basic fundamentals with libcurl transfers is that curl does the transfers pretty basic by default, and then also by sort of nature the same way it used to do it before. So the upgrading usually doesn't change the actual transfer, but it'll work the same way. So when we add new fancy ways of doing transfers tomorrow, usually we do that by introducing new options that allows you to opt into those new fancy ways of doing things. So when you write your application and you upgrade libcurl over the years, it doesn't actually change the transfers unless you opt in to use the new fancy features by setting new options that we introduce. The API is also made in a largely protocol agnostic way, meaning that we talk about transfers more generically, and usually we don't force users to know a lot about the protocol details, but we try to talk about transfers in a more of a general way. And I think you'll see that, and I'll mention, it'll be many examples of that going forward. And we always change behavior so we have a default behavior, and then you change the behavior by setting options. We'll also get into a lot of that. So pretty much everything in curl is oriented around transfers, and one transfer in libcurl is a curl handle, often called an easy handle. And it's called, this is sort of the type def in source code. It's called curl in uppercase, a curl pointer. And that is a handle, and it's an opaque pointer, so you can't see it. It's not a struct, it's just a pointer, like the file pointer you're used to in C for standard out and file management. And this identifies a single transfer, and you should and can reuse this handle because it's a benefit to reuse the same handle again for multiple transfers, because curl will do keep a lot of caches and state in this handle the object to, and it is beneficial to reuse that. Things will run faster. Options are also sticky, so when you set an option, the option will remain. Even if you do multiple transfers, if you set an option, it'll sit there. So if you enable the verbose mode, it'll be verbose until you switch it off again, and so on. And if you set a string, options will copy that data. So if you set a string to an option, because there are many options that it will accept a string, and then libcurl will copy that string, the contents of the string, which is, I'm telling you, because then you know if you use a temporary buffer, that's fine, because curl will copy it. You can free the buffer after you told curl about it. The URL is the only mandatory option I mentioned, and we have a lot of callbacks in curl, so that is pretty much how you get in and out data. Some of the options actually take file names, but a lot of options take callbacks. So you tell curl the function to call to do a lot of different things, and we have, I don't know exactly the exact amount, but maybe it's 10, 15 different callbacks. You provide the function, you pass it to curl, and all those options end with the word function. If that's a callback option, set the callback. And each callback also takes an optional extra pointer. The pointer of your choice is just passed on to the callback by libcurl. Libcurl doesn't understand the pointer. It'll just pass it to the callback as a way for you to pass, local data from your application to the callback, so that you don't have to use global pointers or anything. And so it's 10, 15-ish number of callbacks. They all end with function or data when they're related to callbacks. And it calls those functions when it needs to get things done. What things? Yes, right, okay, first, don't call libcurl functions from within callbacks, because that's discouraged and it actually doesn't work. But there are a few exceptions, but we'll get to them maybe. Okay, so just to reiterate three sort of pillars, fundamental concepts in the libcurl API. We're talking about these opaque handles. They don't point to anything, but they're specific for holding. For example, the easy handle, it holds one transfer. We talk about URLs to do transfers, and we have a lot of callbacks. Those are the three basic things, and they will come back for a lot of things within the API. So I'm talking about the easy interface here, and the easy interface is actually named the easy interface because it is easy. I'll agree that it is kind of a silly name, but I picked it early on and it sort of stuck, and we couldn't really change it. Okay, anyway, so the easy interface, that's the way how you do synchronous transfers. You pretty much set things up, do a transfer in a single function call, and it'll do the entire transfer before it returns. So that's why it's a synchronous transfer. If it's a slow transfer or a huge transfer or whatever, it might take a long time until the function returns because it's a synchronous function call. And it'll perform until it succeeds or fails, right? Until it's done, pretty much. It'll then by default run as fast as possible, which, usually the network is what slows things down. So usually as fast as possible is as fast as your network allows it to run, unless of course you run it on local host, then that's a CPU bounds or how fast curl manages its data internally. But typically it'll be fast enough for you. And you can then you can set options to limit, for example, how long it'll be allowed to take or how fast it will be allowed to perform and so on. So you can tweak that. So you create an easy handle with the function called curl easy init. Easy because it's an easy handle, and init because we have a lot of setups like that. Init to create it, clean up to kill it. Here we create the easy init, and you get a handle to a object that is a transfer. Of course, when you just created it, that's not really a transfer yet because it's hasn't started, but it's a potential transfer. And it gets initialized then with a lot of default values. You don't know what default values, it's just in there. And similar to file I mentioned already, and you kill it again with curl easy cleanup when you're done with it. So every init has a cleanup somewhere to get rid of again. And after you've created it, you can set options. In this case, example here on the screen, you set the URL. In this case, https://curl.sc. We want to do a transfer of the curl web site's main URL. Well, that's an HTML document really. So doing this, you ask for a URL to get transferred, but it doesn't do the transfer. You just set the option here, and you could then potentially set a lot of different options. And also what's fun is that this function, curl easy setup, which sets options for the easy handle. There are plenty of options, and they all take different argument types. So in this case, the URL, it takes a string, and that's why you see it's taking a string here. The URL is a string. But other options might take a long or other kinds of pointers and so on. Basically, you just have to check the option, read the man page, see what kind of input does it want or need, and then you make sure that you pass on the right type. Which is sometimes a little bit confusing, or you have to sort of just read up and see how to use it, what kind of data it needs. And some of the options that are common things, you set the URL, of course, for the transfer. Verbose mode, if you wanted to speak a lot, for example, and tell you about what it's doing. Buffer size is how big internal buffer libcurl will use when it does downloads. You can sometimes gain a little bit of a speed to increase this, especially if you intend to do downloads over on localhost or something where the network is extremely fast. Error buffer is a way for you to get better error messages. Write function is a way for you provide a function to libcurl to write data that it receives. Reading timeout is the maximum time you allow it. Connection timeout is the maximum time you allow it to spend trying to connect to a server, and so on. Bunch of options here. That's just a small selection. There are over 300 curl easy setup options. So there's really an ocean to drown in when it comes to options. So pretty much whatever you want to do to tweak the transfer, there's probably a curl opt already there for you to set and tweak and adjust the transfer to be exactly how you want it to be. And to do the transfer, it's just this call, curl easy perform. It performs the transfer using this easy handle. The easy handle was already set up as shown in the previous slide. So it will perform the transfer until it's done and then return, and it returns a curl code, which is then a return code. One of them is okay, then the transfer went exactly as you asked. All the others are error codes, then of course we'll describe what went wrong. Pretty straightforward. So when you want to write this then into an actual source code, you have to know that you need to include this header file. This is the single only header file you need to include in your libcurl using application, because that's the way we have sort of mushed it all in. So if you just include curl/curl.h, then you can use the libcurl or everything in the libcurl API just fine. Whatever function you want to use and all the defines, etc., etc. So then a minimal easy example then, so how to do a very easy way, a very basic internet transfer using libcurl. Of course, this doesn't show the actual include that I just said, but we have to use. But so imagine an include above this, and then you create the easy handle. If it worked, if it fails, it'll return a null. So then, okay, if it worked to create an easy handle, you set the URL. Let's get example.com, an HTTPS URL. And hey, let's follow redirects. Tell curl, hey, we want to follow redirects, which is called follow location, because it's a location : header in HTTP. And perform that transfer. And when it'll happen, it'll return the return code into this res variable, which isn't declared in this source code. And if it's not okay, then we can, for example, like this, display the error, curl easy error. And then we clean up the handle and we're done. That's all you need to get that URL transferred to you. So you may then, of course, ask, so where does it go? What happens? You download the URL, but okay, this example here is very easy and small and stupid, really. It doesn't tell libcurl where to put the data, so it'll have a default way to put it, and that's on standard out. So this is basically just spewing out the HTML from that URL on standard out, and then it'll be done. So you init the handle, you set up the options, you do the perform to do the actual transfer, and then you clean up the handle. Those 4 steps, of course, you might do quite a few setups depending on what you want to do, but still, init, setup, perform, cleanup. It's that easy. So then that example I showed you was a little bit too simplified, maybe. But so, for example, if you want to get data from a remote place, that is, you want to download something, then you want to store it somewhere, then you tell curl, you give libcurl a callback called a write function. So when libcurl get data and it wants to write it somewhere locally, that's the write function. So that's the kind of view. So pretty much you provide this callback. This is an example. We call it write CB for callback, and it'll get the contents, the size of the contents, and the 4th argument here called user P. That's the pointer that you gave libcurl in this extra option. So pretty much here, for everything that is downloaded by curl is then provided to this write callback over and over and over again, chunks by chunk by chunk by chunk. If it's a super big download, it will be called many times. If it's a tiny download, maybe just called once or twice or 14. So that's basically what you need to do in this function. You need to handle the data, then return the number of bytes that you actually took care of, which should be all the bytes. If you didn't take care of all the bytes, libcurl will consider that an error and stop the transfer. And if you want to do it the other way, you want to upload data, because why not? You want to upload something, then there is a little bit more complicated. It's not actually, but we provide more options to do that, because there are possibly more chances that you want to do. For example, you can do the complete opposite to the write function is the read function. You just provide a callback. You provide a function that will send the data to libcurl when it wants to upload something, however you want. You can read it from a file, from data in memory, and invent it at runtime, whatever. Or you can provide this post fields, which is the way for you to provide a pointer to data for libcurl to send. Typically, and the name post fields comes from how it was created for HTTP post. So it's usually by default it's used for HTTP post. Or you can use this mime post option. That's for multi-part form posts with HTML, because they're formatted in a way to doing mime boundaries and things. So you have to create that data using the mime API in libcurl. Slightly more complicated, but also much more powerful. For example, that is how browsers typically do file uploads and image uploads and do complicated forms and stuff like that. Then you sort of have to create the data properly, and that's what you do with the mime API, and then provide it with mime post. But for example, then a very minimal easy post example, just sending a tiny simple basic HTTP post with libcurl. Really easy peasy. Create the handle, right? Init, setup, perform, cleanup. I said. So init, setup. We want to send the data there, and hey, we want to send this hello string. And since we set this in the post fields, this turns the operation into an HTTP post, and it will send an hello in there. And then we perform it. And then maybe there's an error, show the error. If it's not, or either way, we clean up the handle and we're done. So this sends an HTTP post to example.com over HTTPS. Easy peasy. Okay, so you downloaded, you uploaded. So when you've done a transfer, maybe you're interested in some transfer information. What happened in the transfer, right? How many data did we send? How much data did we get, and so on. So then we have the curl easy get info, and then it is similar to in that it uses an easy handle, and you tell get info what kind of info you want extracted from this handle, because this handle keeps a lot of information from the previous transfer. So after the transfer is done, ask for particular stuff. For example, you can ask for the effective URL that the transfer was about. It actually then is the, if it did the HTTP redirects, it could have followed redirects a number of steps, but on which URL did it end up on? This one tells you. Or which HTTP response code was there in that response? Ask for it. Or how long time did it actually take to do the entire transfer? Or how fast did it download this transfer? And what was the content type of the HTTP resource that you actually got? All of these you get easily and conveniently with this function. And there are many more options there. I think there's in the range of 70 or 80 options for you to get from previous transfer. There's also actually an entire separate header API if you want to get specific headers from an HTTP response. But I'm actually not going to talk about that API today. So the header API you can read up on about yourself. So anyway, so just to show you then the example, my init, setup, perform, cleanup mantra, those 4 steps then get extended, because here you did init, setup, you do the perform, but after the perform, maybe you want to figure something out about the transfer. So in this case, if the transfer went okay, check out, ask libcurl, what was the content type actually in that response? And if that works, show the content type. And the content type might be a silly example, in particular, since we have a header API now, so you can ask for any header you want. And you should use the header API instead. But this is just a way to show you one particular option to get info. There are lots of others. So, and easy, it just extracts the info you want to know. And it has a lot of info. But of course, quite often, at least while during development, things don't actually work the way you want it to. You want to do a transfer, but for some reason it doesn't do the transfer the way you want, or you don't get the data you want, or something is wrong, right? And how? Then I just want to tell you about what mechanisms we provide to help you as a developer using libcurl to figure out what's actually happening and what's wrong and what you can do next. So debugging a libcurl using application, of course, make sure that you actually read the documentation for the options and functions you use, because we do try to document them thoroughly. So it's quite possible that the details are in the docs already. And you have to make sure, sometimes I'm sloppy when I write example codes, for example, in some of the standalone examples for libcurl, they don't really check the return codes properly, but you should, because sometimes some of the functions actually return an error that it would explain why it doesn't work, right? And then you enable the verbose option, which makes it quite a lot more talkative, and then even explaining in several ways why it does what it does, and it shows you which headers it gets and so on. And so you'll see much more of the actual transfer under what's happening under the hood. You can provide this error buffer, which is just a buffer you tell libcurl, hey, write in an error message in this buffer when something goes wrong. And it's often a better error for you because it's more context sensitive, because it could include details about this particular time it ran into a problem. And then if you want to go even further, there's this debug function callback, which is a way for libcurl to provide a lot of debug function in runtime of data it sends, gets, and so on. It's very helpful. It's also very verbose. It's much more verbose than the verbose option itself. And of course, when you write and you use libcurl, you can, if you use C or any other memory unsafe language, Valgrind is really your friend to make sure that your code is also not doing something bad. And if you still sort of struggle with using libcurl, there's always free support on the libcurl mailing list, and you can also use the discussions thing on GitHub. And if you find bugs, actually, it doesn't actually do what it says it should do, or something like that, you know, file a bug report. We also are very quick to respond to bug reports. And of course, we're always welcoming new customers for commercial support, and then we can do everything privately and help you out with whatever issue and problem or challenge you have. So that I've just shown you how to do synchronous transfers up and down, and I just wanted to briefly mention that going next level, maybe not when you're not getting started anymore, but this is more like chapter 2, but I want to give you a quick taste anyway. Then you can do multiple parallel transfers in the same thread, right? So that is how, and you can then sort of add and remove transfers as you go. That's sort of the cool way to do many transfers using libcurl. And pretty much you then create a setup easy handles exactly as I showed before, because one easy handle is still a single transfer. And then you create a multi-handle, you add all those easy handle to the multi-handle, and then you drive all the transfers concurrently in parallel. And I'll show you just quickly, because you can read up about these details yourself, because it's really not getting started anymore. So you create a number of easy handles, in this case 2. You set options to the easy handles, as I mentioned. You create a multi-handle. You add the easy handles to that multi-handle. So you can add 100 easy handles to this multi-handle. And then you drive all the transfers at the same time. Curl multi-perform, it drives any amount of transfers in parallel in the same thread at the same time. So now it fires off a busload of transfers, and it'll be going, as long as there are transfers going, we can wait and time out and do something else if we want to every once in a while. Otherwise, if we check, is there any transfer completed? Yes, then we can manage handle, oh, that transfer completed. And then we loop. So we keep on doing this until all the transfers are done. In this case, of course, this example, just 2 transfers. But anyway, we continue the looping to do all the transfers until both transfers are done. Then we remove the handles again. We clean up the multi-handle, we clean up the easy handles, and we're done. I'm just showing this basically to prove that it's really, really easy to convert from that synchronous single transfer serially 1 by 1 over to this multi way to do many transfers at once in case you need to and want to. You can, of course, also do the synchronous transfers in separate threads instead if you want to do that. Completely cool, that too. Yeah, let's not skip the details about the multi-interface. But as I mentioned, you can do them synchronous transfers in multiple threads too. libcurl itself is always single-threaded, so all of these calls I've mentioned so far, they're all in the same thread. So you will get the callbacks, get the return, everything is in the same thread. Curl will not start new threads for you. So if you can, then of course, if you want to go more, imagine that your CPU bound in your thread, for example, you can create more threads to get more transfers done. And that's totally fine, as long as you don't share curl handles between threads. It works perfectly well, and it performs really, really well. One of the benefits of doing multi-interface instead of doing separate threads is, of course, caching, because and caching and state is better kept on the single thread. And so that's what, then you have transfers going pretty nicely. And I wanted to then just mention that there's, if you want to spice things up a little bit, or in a lot of transfer use cases, you also have URLs somewhere involved, and often then you want to either parse URLs or create URLs, or both. So in libcurl, we have an API for that. And this is managing URLs. I call them RFC 3986 Plus because it's based on the 3986 spec, but somewhat extended because URL specification is, I mean, there's no one that really works for everyone. So it's a bit of an unfortunate situation, but I'm not going to talk about that today. You can parse, change, generate URLs with this. And this is similar than that you're working with a handle that represents, in this case, not a transfer, but a URL. So you create one of these handles with curl URL, and then you work on it for, well, you can also duplicate it. But then, for example, if you want, you set things in the handle and you get stuff out of the handle, you can set URL parts to add them to the handle. And then you can get them then to extracts. Like this. Here's a URL, well, a sample URL really. Scheme, user, password, host, port number, path, query, and fragment. There can be some extra components too, but pretty much all of these components can be separately managed by curl and with the curl URL API. You can set them and extract them, or you can set the entire URL at once. So then we deal with them like this: curl u part and then the name of the component. And these are the different parts, really, URL parts. So you can URL, scheme, user, password, options, host, zone ID, port, path, query, fragment, set and get all of them independently, including the full URL. So for example, I didn't have the example here. So pretty much you can set the URL and then you can extract, for example, the port number, the path, the query, the fragment, or the other way around. Set the user, password, host, and fragment, and then get the complete URL that was created by those different components. And there's really a lot more to say about the API, but this is just getting started. So I'm just wanted to get the basics in here. So I wanted just to mention that I did this mastering libcurl videos. There is actually 2 episodes of this. I did this last year, I think. So you can check that out. It goes into more detail because than I've done today. Of course, there are 2 parts. I think it's a 4-hour total or something. Totally insane, amount of stuff. But fast forward, find the chapters you want to see, learn, and do that. And of course, I try to get everything there is to say about curl into everything curl. Funny how that could work out. But in that, it's an online book, and it's available as website, EPUB, PDF, whatever you want, and it's totally free. Again, I mentioned we offer curl commercial support for curl, so get in touch if you need that. And I also just want to remind you, everyone, that curl is entirely open source, and you can always help out. Report bugs, bring your own pull requests, or bring your discussion to us about what we should do next or not do next or whatever. And that's what I wanted to bring to you today. So on questions, I got one question here that I wanted to just get to right away. So I got a question here. I'll read it out loud. Could you briefly describe a common use case for the multi-socket interface and how it differs from using the normal multi-interface that you showed? Okay, yeah, but I went through that very quickly, so I didn't really explain it, but thank you for asking. So there is this normal multi-interface, which is the one I showed you an example of how to do. It works really well, and it's easy to use, and it does many parallel transfers in parallel concurrently, and it works great. But it has its API is so easy and simple that it actually doesn't scale very well when you go above a certain amount of transfers or connections that are involved. So maybe at some point when you go maybe above 100, 200, 1,000 transfers in parallel, it doesn't really scale anymore, because that's an API that really forces you to use either select or poll. And select or poll, there are great function calls. They were created I don't know, 40, 50 years ago, but they don't scale very well up after a certain amount of transfers. And that is why I once introduced the multi-socket interface, which is an event-based interface, which then allows you to work on each socket one by one when something happens. You don't have to deal with them all, like both the poll and the select function calls. You have to deal with all the sockets in every function call, which makes it have to iterate over so many sockets over and over and over. It's not a very optimized way to do it. The socket interface instead is much more performing in those situations, but it's also a more complicated API. So I usually say you should avoid the socket multi-socket interface if you can, but if the regular multi API isn't good enough or it doesn't scale good enough for you, then you can switch to the multi-socket interface. And I mean, I've had users years ago doing, you know, in the range of 30K parallel transfers or something with libcurl. So it does scale really well up to that amount if you're using the multi-socket interface. Of course, the network might be, or the CPU might be a limiting factor then also. Okay, so I had another question also here. When should I clean up easy handle on successful transfer? Does it keep a connection open? That's a very good question, and I should probably have emphasized that a little bit more. So the easy handle keeps connections alive. It has a DNS cache. It has a range of different caches that it maintains in the handle, and that's why if you do one transfer and you intend to possibly do another transfer, you should really not kill that easy handle. You should use it again for your next transfer. And in particular, if you use the transfer to the same host name and the same port number and everything, then it will most likely just keep the connection alive from the previous transfer, and it'll use the same connection again in the second transfer, which makes the second transfer much faster than having to set it up all again. So if you would kill the easy handle and create a new one for each loop, for example, then it'll become dreadfully slow because you have to close it down and set up new connections all the time. And sometimes, you know, setting up a new connection and do the TLS and verification of the server and everything, that can be really slow. So you have a lot to gain by reusing the easy handles as much as you can, really. And that really goes for many of the other handles too in curl. So they try to keep stuff cached so that if you do things again, it can actually benefit from that.
Wonderful. Well, thank you, Daniel, so much for hosting an informative webinar. Thank you to everyone for joining. I will email a copy of the webinar recording and the PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions, please reach out to us at facts@wolfssl.com. Thank you again, and we look forward to seeing you tomorrow for getting started with wolfSSL in 2025. Thank you all.